So thank you very much. First of all, it's good to be back. 25 years ago, I was roaming these same corridors. I'm actually an alumni, graduated in 1995. And when I first came here, this building was not even finished. So it's quite amazing how much this place has grown. So thank you for having me. It's good to get the day off the madness and look a little bit from a different perspective at I guess, our industry. A few words about Qualcomm. The company is about 30 years old. I've been with the company about 20 years. And we're pretty big, about $100 billion capitalization, $25 billion revenue per year. We're not very well known, unlike Intel, but when it comes to mobile and ARM-based ecosystem, we're essentially the #1 fabless semiconductor company. We don't have our own fabs, but we're the ones consuming the most silicon in terms of revenue, or generating the most silicon in terms of revenue in the world. Our roots are in wireless communication, and unsurprisingly, we have the largest number of installed cellular communication, 3G and 4G, in the world. There's other, like we ship the most graphic GPUs in the world. It's not known. First half of the year, there was just a report today, we shipped the most application processors in the world. So we're not a brand, but pretty much all of you have our silicon in your pockets. Just to give a sense of scale, in last year we shipped a little bit shy of 1 billion platforms. So it's not chipset. Chipset would be north of 5 billion chips. It's really chipsets which include more than one chip component. We have effectively two business and revenue stream. One is, and we're all about enabling technologies and providing this technology to the ecosystem. One way we do it is through silicon, and the other way we do it is through licensing. So as I said, we're all about providing technology and providing it at scale. I've been fortunate enough to join, as I mentioned, about 20 years ago. And it's very rare in a career to be able to work on things that eventually are in the hands of billions of people. And that's what I've been given the opportunity to do, working initially on 3G and 4G system design and standardization for about 10 years, and now moving to the silicon side of the house in the past 5-6 years. So as I said, we're providing technology at scale. We initially did it in mobile. So our motto is we lead in mobile. And as the growth in mobile is kind of a little bit less than it used to be, but there's still growth in mobile, by the way, we're applying this technology on this scale to other industries. And typically, in our core, we would take what we'd say technology risk, where we innovate on technology and enable it for the mobile system. In those industries, for now, we're essentially going for channel risk, which means we're taking our technology that we develop for the phone and we apply it to new industries where the technology is mature, but our understanding of the channel is not there, at least initially. And then we grow into these channels. The other thing that we've done, and there's a sense also of scale in terms of cumulative R&D spend through the life of the company, 33 of those 41 billions have been spent in the last 10 years. And the run rate is, I think, in the order of 4 to 5 billion a year. What's happened is we started with connectivity, and then we added a processor, and then a graphic, and then location, and so on and so forth. And little by little, there's been a morphing, as Professor Atienza described, between what we used to call connectivity and compute, to a point where now essentially compute is being sort of taken over by the smartphone side, except potentially for servers and really high power computing. And there'll be more to come in that space, but essentially it's been a complete substitution that's happening under the hood. So coming a little bit closer to wearable, as I mentioned, we're essentially leveraging the scale and the technology that we've developed for smartphones and applying it to other industries. Automotive is one of them. Mobile compute is the one I just discussed, with ARM-based computing that's continuously growing and emerging as something to essentially replace the traditional computing, at least in terms of consumer. Networking and IoT. IoT is obviously a very vast domain, and we essentially try to identify the different areas and group them so that when we go and look at the channel, the different partners we need to work with, there's kind of a pattern and a common theme in terms of the technology and the way we package it together. So there are essentially three pillars that the way we've organized ourselves. One is smart wearables, which means things people wear on them. The other one is smart homes, which is really consumer. These two things are consumer IoT. This is consumer IoT that's being on people. This is consumer IoT that's not on people, but that people interact with or touch or install. And this is non-consumer IoT. And another way to describe it is industrial IoT. So we operate with that model. And for each of those, what we typically do is we essentially look at our technology candy store and try to pick and choose what's relevant to those pillars and aggregate the technology in a way that's relevant to those specific channels. And each of these technologies have typically been developed as part of the smartphone evolution. The challenge is they may not be exactly optimized for these new channels. And there is a little bit of a chicken and egg in the sense that there is huge growth being projected. But for the growth to happen, there needs to be the appropriate technology. At the same time, for the growth to happen, there needs to be the appropriate cost structure. The cost structure comes from the scale of the smartphone ecosystem, but the technology might not be fully optimum. So we have to grind at the problem kind of top-down or sort of laterally, and while being very aware of people grinding at the problem bottom-up, which is where some disruption could happen. And that's exactly what we're doing, sort of addressing initially the markets by leveraging the technology as is, and then as the market takes momentum, optimizing very specifically and surgically specific technology element to accelerate that momentum. I think that was covered earlier today. Wearable vision, I think, is very consistent with what's been discussed earlier. It can be a lot of things, not just a watch. And it can be hearables, glasses, watches, obviously, and then all sorts of other sensors that people will eventually or could eventually wear and carry with them. So in the vision, people will have multiple of these things. They would be connected with each other, and then they'll be connected to the rest of the world. I think the typical model people have is this cloud-based vision, but I'm very much in agreement with some of the comments earlier that for this model to work, there'll have to be a balance between the edge and the cloud in order for the system to be efficient, especially from a power perspective, as well from a data management perspective. I think this is a slightly different way of expressing it, but essentially what I've described, maybe focusing a little bit more on the specific sort of products that the way we do it. We take, and typically the way we've done it for phones and applying it to different channels. So we have technology element with specific capability and properties. Then we have the ability to package them in obviously we have scale in silicon and access to silicon capability that's pretty much unique. We're obviously very engaged with all these ecosystem on top, whether in the consumer space or in the enterprise space. This is mostly listed the consumer ones. And then we have trying to establish a strong network of partners and manufacturers. And then occasionally, we even get in the service space, though we tend to let that to others. So just to give a little bit of a sense of where we are on wearables, we recently, and the way we're committed to it, we recently announced specific chips and components for the wearable space, and I'll describe a little bit more. The important thing here is we use the brand that we've used for smartphone, which is a high-valued brand, the Snapdragon brand, and we're applying it to wearables, which sort of indicates a sense of commitment and long-term engagement in the market. So what we've done so far is introduce two what we call Snapdragon Wear platforms, and they sort of augment and complement a portfolio of products that were a little bit more technology specific that we inherited from an acquisition we did in the UK called CSR. These are the product attributes. They're very general purpose, unlike what was described by Professor Atienza. They're not yet multi-core. So again, general purpose, but that goes with this notion of grinding at the problem and progressively optimizing the platforms as the market takes off. But nevertheless, they have processing capability, OS capability, cellular communication capability at different degree of optimization, position location, sensor, islands, increasingly power optimized, and then enabling rich user interface. There was some example of that this morning, even though that particular example is not using those platforms. So I think, again, summarizing, there's quite a bit of traction. I think the design aspect hopefully will evolve, but these are the type of things we've enabled these brands to do. Michael Kors, LG, Nixon, and there'll be more and more. Actually, we have in excess of 100 designs, and the list keeps growing. Obviously, this is just the beginning, and those solutions are not perfect. And I think coming a little bit more to the forum here, what are the problems that we need to deal with? Obviously, form factor is an important element. We need smaller PCB area is obviously important because you want to leave the most volume for the battery, and therefore we need to continuously minimize the volume used by silicon and the array used by silicon. Display, like specifically on the watch, on the wearables, typically there's always the issue of bezel. You see some of these Android Wear watches, they have this flat tire situation where a chunk of the circle is cut, not necessarily the best design. So there are a bunch of aspects that need to be addressed from a form factor perspective. Ultra low power, continuous steam inherited from the smartphone side, where power is equally important. There's always improvement from an application perspective, from a communication perspective. And again, I think the point made earlier on balancing the local processing, the sensor activity, and the communication component is a very critical one, and one that's not yet been fully figured out. Obviously, charging, given that the battery, as much as we're improving it, is not going to be satisfactory for some time. Battery and fast charging is an important element as well. Smart sensing, obviously high accuracy. I think there were some comments about the heart monitoring aspect this morning. Obviously very relevant if we're trying to do more advanced things and start to rely on this capability that's on our body. It better be precise, predictable, and reliable. Low power, that's a common theme, and obviously optimized, increasingly optimized as the market takes off. Always on connectivity. That doesn't mean the connectivity is active all the time, but it could be activated at any time, and at different degree, obviously local, but increasingly these things, while they work together, may not always be all present at the same time. So the ability for some of these components of the wearable network or the body network to connect independently over phone or hub will keep increasing. And there is good progress from a standard front as well as operator front to evolve the business model. Instead of asking $20 per month for a phone subscription, to ask maybe a few cents or tens of cents per month, or even charge by the bit again, but in a way that's very appealing. As well as in terms of the nature of the communication, like these 4G and 5G systems, they tend to be ultra-wide bandwidth, which is antagonistic to power. So there's different modes that are being introduced now where it's much narrower band, it's power optimized, it's designed for coverage, and therefore improve power and reliability. And obviously the device management and identity aspect is another one that needs to be progressed. Finally, security and location, they kind of bundle together here. They could be treated independently, but ultimately everything that relates to privacy is critically important. At the same time, we need to have precise information as to the location of these devices in order to make the right decision, have the proper context in making decisions and assessments of the situation. So as much as we need accuracy, it has to come with a higher form of security and privacy, because it's getting very personal at that level. So that's kind of what I had. I think there's a lot of meaty challenges here. Obviously, we're working on them from an industry perspective, coming with our heritage. It's very interesting and challenging to come from a 1 billion unit a year machinery that's dealing with about 50 customers or 100 customers, the phone guys, and now having to go back to kind of startup mode with very little revenue to start with, very different customers. In case of industrial IoT, maybe thousands of customers that will use the devices. So the way to sort of deal with the challenge is a little bit different. So it's a lot of sort of reset and learning, and it's kind of very motivating and interesting. But the fact is, this growth that is sort of portrayed as usually exponential can only happen if the technology that is being sort of generated by something that's already at scale can sort of transfer. Otherwise, the chicken and egg situation could remain for quite a long time. So anyway, we're trying to make sure that people are enabled with the proper technology. We're not trying to be too intelligent about how people will use it. We're trying to understand, obviously, but typically technology companies have been wrong about these things. SMS was just an afterthought built in GSM, turned out to be a huge industry. People thought the reason 3G will take off is because of video telephony. That kind of never happened, but it did happen with 4G, with FaceTime and equivalent. So typically, the motto we have is build it and they will come. And enable technology, put it in the hands of the ecosystem, and then the ecosystem is large enough, especially these days, to figure out how to use the technology, and something will emerge and change the world. Thank you very much.